Alrighty guys, so if you're watching this video, I appreciate it. I'm going to just quickly go over how we graph inequalities. I'm going to talk about some of the basic rules. Really, there's just one basic rule. So as I'm adjusting this, pretty much graphing an inequality is almost exactly like just graphing a regular line. You're going to start off by solving for y. The thing is, there's two things you need to consider. That line is either going to be dotted or solid, and that's going to be based on this inequality sign right here. And in addition to that, if you divide by a negative or multiply by a negative at any point as you're solving for a y, then you're going to have to flip that sign. So let's go ahead and get started on this number 6 right here. So the first thing I would want to do if I'm solving for y is I've got to move that 4x over to the other side by subtracting 4x from each side. So I do that, and I'm going to end up with negative 3y still greater than or equal to negative 4x plus 12. So again, what I did was I moved that 4x right here to the other side. It became negative, and I still have a negative 3y on this side. Now if I'm solving for y, I've got to divide by negative 3. When you divide by negative 3 or multiply by a negative, when you divide by a negative or multiply by a negative on an inequality, it flips this sign. So here's my new equation. I've got y, or a new inequality. I have y. That's going to flip directions like that. So now notice it's facing the other direction. I'm going to have negative 4 divided by negative 3 is a positive 4/3 x. And then positive 12 divided by negative 3 is a negative 4. So now I'm good to graph this. I've solved for y. So here's my number by itself. That's my y-intercept. That's my starting point. So I'm starting at negative 4 right here. And then my slope is the number that's attached to the x. In this case, it's already in fraction form, so that's easy. My rise over run, so I'm going up 4, right 3. Up 4, right 3. Up 4, right 3. So up 4, right 3. Up 4, right 3. Up 4, right 3. Okay, so you can see where my line's going to be. Now the question becomes, is it going to be a solid line or a dashed line? So here's just a little bit of notes. If you ever have equal to or less than or greater than or equal to, one of those signs, then your line is going to be solid. If you have strictly less than or strictly greater than, then your line is going to be dashed. So in this case, we've got less than or equal to, so my line is going to be solid. Okay, so there's my line. Now the question is, where do you shade? So I've got y is smaller than this line that we just drew. So the way I was showing you guys in class was, if I take my pen and I put it on the y-axis, where this line hits the y-axis, so right here, then, and I read this inequality, it says y is smaller. So where are the y's smaller? It's either up or it's down. Okay, so, and I'm looking at the y-axis. So all my bigger y's are this way, my smaller y's are downward. So here's my smaller y's, and that's what this is saying, y is smaller. So now if you notice where I put my line, that's the same side of the inequality that I need to shade on. So I need to shade everything on this side of my inequality. So here are all my solutions, anywhere in this shaded region. And if I just select any point in that shaded region, then it's going to be a solution. So let's go ahead and select, let's say 5, 0. That should be a solution. And the way I could find out is if I took this and plug it into this equation. So let's go ahead and do that real quick. So 4 times 5 minus 3 times 0 is greater than or equal to 12. So I rewrote this exact equation right here, right there, but instead of x and y, I used my coordinate point. So I've got 20 minus 0 is greater than or equal to 12, which is a true statement. 20 is greater than or equal to 12. So great. there's an infinite amount of points that will actually work on this, and that's why you have a whole shaded region. You can select anything in the shaded region. Additionally, because it's a solid line, I can also select points that are on that line. If it is not a solid line, if it's a dashed line, then I cannot do that. So real quick, I'm going to speed up the process now. I'm going to do number 7. So I need to add 2x to both sides first. So I've got negative 4y strictly greater than 2x because I added to both sides, and positive 8. I need to divide by negative 4. When I do that, my sign is going to flip directions, just like that. 2 divided by negative 4 is going to be a negative 1 half x, and then 8 divided by negative 4 is going to be negative 2. So there's my starting point. Negative 2, I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And I just keep repeating that process until I have enough points to make me a line. Okay, so there's my line. Because it's strictly less than, like I said right here, it's going to be a dashed line. So I'll go ahead and actually just use every other point to make it a dashed line. Okay, so there's a dashed line. And again, do we shade above or below on this line? So like I was saying earlier, take your pen, put it where it intersects that y-axis, and read this inequality to yourself out loud. So y is smaller than the line I graphed. So where are the smaller y's? It's either up here, but those y's are all bigger, or down here. There's the smaller y's. So down here is the smaller y's. And again, so if I'm shading right there, then I want to keep shading on this side of the inequality. So any of this area right here, that's the shaded region. So I can select any point from that, and it'll be a solution. So I'm just going to go ahead and select negative 5, negative 5. Okay. So there's that one, and if I wanted to check that, I would just come up here and plug it in, and it should work out for that. Next. Let's go ahead, let me see. Let's do one that's not negative. So this one. I'm going to start off by solving for y. I'm going to move the 6x to the other side, so I've got 3y less than or equal to negative 6x minus 12. Next, I'm going to divide by that 3 right there, or this 3. So I'm going to have y less than or equal to, and because I'm dividing by a positive number, my sign's not going to switch. Negative 2x, and then negative 12 divided by 3 is going to be negative 4. Okay, so again, I want to restate that. Only if I divide by a negative number or multiply by a negative number does the sign switch. Okay, so in this case, we divided by a positive number. Sign did not switch, so I'm good to go. Negative 4 is my starting point. My slope is down 2, right 1. Okay, my line is going to be solid because I've got that line on the bottom. It is less than or equal to, so it's a solid line. Oh, that is terrible. That's all right. I think you get the point. So, solid line. Again, question is, do I shade above or below? Well, there's where it should be intersecting the y-axis right there. It says that the y is smaller than the line I graphed. So where are my smaller y's at? Well, again, the y's are bigger right here. So my smaller y's are right here, right? So there's my smaller y's, and so I'm shading on this side of the line. I just continue shading on this side of the line. Just to avoid common misconceptions, well, let me go ahead and pick out a point, any point in here. So I'll do negative 5 again. So like I said, this point, or any point in this shaded region, should be able to satisfy that equation. I want to look back up at this one that we just did a second ago. Because this is a dotted line, if I choose a point that is on this dotted line, it will not satisfy that inequality. Because this is a solid line, if I choose a point that is on the solid line, it will solve that or satisfy that inequality. So again, just to avoid common misconceptions, people often assume that just because this thing is opening in this direction, that means I'm going to shade somehow on the right side of the line. That's not true. Don't try to memorize just rules. Just understand what you're doing. So this says that y is smaller than the equation we just graphed. Here's the equation we just graphed. All the smaller y's are down this way. So I got a shade on this side. Okay? Or again, this is saying that y is smaller than the equation we just graphed. Here's the equation we just graphed. Here's the smaller y's. Shade on this side. Man, I didn't do any greater than. That's unfortunate. Well, I think you guys get the point. If not, my tutoring hours are still the same. You should come in and just get some one-on-one help. I hope this video helps, and I will see you in class.